Hello everyone, I'm Professor Diwa and welcome to another math video. In this video, we'll be going over more graphs of quadratic functions. Our objectives are to write quadratic functions in the form y equals a times the parentheses x minus h squared plus k. Find the maximum or minimum value of a quadratic function. Alright, so let's get started. For example number 1, write the function in the form y equals a times the parentheses x minus h squared plus k. Find the vertex and any intercepts. Here we have the function g of x equals 3x squared plus 12x plus 13. What we need to do here is rewrite the function in the given form y equals a times the parentheses x minus h squared plus k. Notice here with this form that we have a perfect square. This means we're going to have to complete the square. Also, we have the value a in front of the perfect square. This means we're going to have to factor out a value a before we complete the square. So the first step here is grouping together the two terms with the x variable. So I have parentheses around the 3x squared plus 12x, and then we have plus 13 on the outside. Next, we're going to factor out the common factor of 3 outside of the parentheses, and this will be our value for a. So we have 3 times the parentheses, x squared plus 4x. We leave a space for completing the square, and then we have plus 13 on the outside of the parentheses. Alright, so from here we're going to complete the square. We're going to take the coefficient of x, which is 4, take half of it, square it, and then we'll add and subtract that number inside the parentheses. So half of 4 is 2, 2 squared is 4, so we're going to add and subtract 4 inside of the parentheses. We have 3 times the parentheses, x squared plus 4x plus 4 minus 4, and then we have a plus 13 on the outside of the parentheses. The next step here is taking out the negative 4 so that we can have a perfect square inside of the parentheses. To take out the negative 4, we just need to distribute the 3 to the negative 4. 3 times negative 4 is negative 12, and then we bring down all the other terms. So we have 3 times the parentheses, x squared plus 4x plus 4, and then we have minus 12 plus 13 on the outside of the parentheses. Next, we simplify. Negative 12 plus 13 is plus 1, and then we factor the x squared plus 4x plus 4 as a perfect square. The result is 3 times the parentheses, x plus 2 squared plus 1. So our function is now in the correct form. We have g of x equals 3 times the parentheses, x plus 2 squared plus 1. The value for a is 3, the value for h is negative 2, and the value for k is 1. The vertex is at the point h comma k, so we have parentheses negative 2 comma 1 for our vertex. Next, we need to find the intercepts. First, we're going to find any x-intercepts. We just take our function g of x, set it equal to 0, and solve for x. So we have 3 times the parentheses, x plus 2 squared, plus 1 equals 0. Next, we get rid of the positive 1 by subtracting 1 from both sides of the equation. The result is 3 times the parentheses, x plus 2 squared, equals negative 1. Next, we get rid of the 3 in front of the parentheses by dividing both sides by 3. So we have 3 times the parentheses, x plus 2 squared divided by 3 equals negative 1 divided by 3. After simplifying the equation, we get parentheses x plus 2 squared equals negative 1 over 3. The next step here is getting rid of the square by taking the square root of both sides of the equation. The result is x plus 2 equals plus or minus the square root of negative 1 over 3. Next, we could get rid of the positive 2 by subtracting 2 from both sides of the equation. Also, we could take out the negative 1 from the square root and rewrite it as I. The result is x equals negative 2 plus or minus the square root of 1 over 3i. Because the result is a complex number, this means that we have no x-intercepts. Next, we're going to look for any y-intercepts. To find a y-intercept, we just take 0 and substitute it in for x into the function g. We get g of 0 equals 3 times 0 squared plus 12 times 0 plus 13. After simplifying, the result is g of 0 equals 13. This means that our y-intercept is at the point parentheses 0, 13. Next, we have a practice problem. Write the function in the form y equals a times the parentheses x minus h squared plus k. Find the vertex and any intercepts. Here we have the function f of x equals 2x squared minus 16x plus 25. Alright, so go ahead and pause the video, take your time working out this problem, and then check back with the video to see the solutions. Alright, so let's go over the solutions. First, we're going to take the function f and put it in the correct form. We group together the first two terms, so we have parentheses 2x squared minus 16x, and then outside of the parentheses we have the plus 25. The next step here is factoring out the value for a, which is going to be 2, and then leaving a space for completing the square. So I have 2 times the parentheses x squared minus 8x, and then leave a space for completing the square, and then we have a plus 25 outside of the parentheses. To complete the square, we take half of negative 8 and square it. So half of negative 8 is negative 4, and then negative 4 squared is 16. Next, we add and subtract 16 inside of the parentheses. So we have 2 times the parentheses x squared minus 8x plus 16 minus 16, and then plus 25 outside the parentheses. From here, we're going to take out the negative 16 by distributing the 2 to the negative 16. Multiplying those two together, we get negative 32, and then we bring down all the other terms. So we have 2 times the parentheses x squared minus 8x plus 16, and then we have minus 32 and plus 25 outside of the parentheses. Next, we factor the x squared minus 8x plus 16 as a perfect square, and we also combine the negative 32 and the plus 25. The result is 2 times the parentheses x minus 4 squared, and then we have a minus 7 on the outside of the parentheses. Now that our function's in the correct form, we have f of x equals 2 times the parentheses x minus 4 squared minus 7. Our value for a is 2, the value for h is positive 4, and the value for k is negative 7. This means our vertex is at the point parentheses 4, negative 7. Next, we need to find our intercepts. For the x-intercept, we take our equation and set it equal to 0. So we have 2 times the parentheses x minus 4 squared minus 7 equals 0. We solve for x by first getting rid of the minus 7, so we add 7 to both sides of the equation. The result is 2 times the parentheses x minus 4 squared equals 7. Next, we divide both sides by 2, so we have 2 times the parentheses x minus 4 squared divided by 2 equals 7 divided by 2. After simplifying, we get parentheses x minus 4 squared equals 7 over 2. From here, we need to get rid of the square by taking the square root of both sides of the equation. The result is x minus 4 equals plus or minus the square root of 7 over 2. Next, we get rid of the minus 4 by adding 4 to both sides of the equation. The result is x equals 4 plus or minus the square root of 7 over 2. This means that we're going to have two x-intercepts. The first x-intercept is at the point parentheses 4 minus the square root of 7 over 2, 0, and the second x-intercept is at the point parentheses 4 plus the square root of 7 over 2, 0. Next, we're going to find our y-intercepts. We just substitute in 0 in for x into the function f. We get f of 0 equals 2 times 0 squared minus 16 times 0 plus 25. After simplifying, we have f of 0 is equal to 25. So our y-intercept is at the point parentheses 0, 25. Next, we're going to go over the vertex formula. It states here that the graph of the function f of x equals ax squared plus bx plus c when a is not equal to 0 is a parabola with the vertex at the point parentheses negative b over 2a, comma, f of negative b over 2a. So the vertex formula comes in handy whenever we're trying to find the vertex of a parabola written in this form, and we don't need to graph it. In example number 2, find the vertex and any intercepts. We have f of x equals x squared minus 6x plus 8. To find the vertex, we're going to use the vertex formula. Our function is written in the correct form, so our value for a is 1, our value for b is negative 6, and our value for c is 8. Now we apply the vertex formula. First, we're going to find the x-coordinate, which is x equals negative b over 2a. We substitute our values for a and b, which is 1 and negative 6. We get x equals minus parentheses negative 6 over 2 times 1. After simplifying this, we get 6 over 2, which is equal to 3. So we have x equals 3 for the x-coordinate of the vertex. Next, we find the corresponding y-coordinate by taking the value of 3 and substituting it into the function f. We get f of 3 equals 3 squared minus 6 times 3 plus 8. Next, we simplify. 3 squared is 9, minus 6 times 3 is negative 18, and then we bring down the plus 8. Next, we combine the 9 and negative 18, which is negative 9, and then we bring down the plus 8. Next, we go ahead and combine negative 9 and 8, which is negative 1. So we have f of 3 equals negative 1. Our vertex is at the point parentheses 3 comma negative 1. The next step here is finding any x-intercepts. We just take our function f and set it equal to 0. So we have x squared minus 6x plus 8 equals 0. We could go ahead and factor this, which is parentheses x minus 2 times parentheses x minus 4 equals 0. Next, we apply the zero factor property. We get x minus 2 equals 0 and x minus 4 equals 0. Solving the first equation for x, we just add 2 to both sides. The result is x equals 2. Solving the second equation for x, we just add 4 to both sides of the equation. The result is x equals 4. We have two x-intercepts, which are at the points parentheses 2 comma 0 and parentheses 4 comma 0. Next, we need to find any y-intercepts. We just take 0 and substitute it in for x into the function f. We get f of 0 equals 0 squared minus 6 times 0 plus 8. After simplifying, we get f of 0 is equal to 8. This means we only have one y-intercept at the point parentheses 0 comma 8. Next, we have a practice problem. Find the vertex and any intercepts. We have the function f of x equals x squared plus 4x minus 5. Alright, so go ahead and pause the video, try out this problem, and then check back with the video to see the solutions. Alright, so let's go over the solutions. First, we find the values for a, b, and c. So we have a is equal to 1, b is equal to 4, and c is equal to negative 5. We just substitute these values into the vertex formula. Starting with the x-coordinate, we have x equals negative b over 2a. This is equal to negative 4 over 2 times 1. After simplifying, we get negative 4 over 2, which is negative 2. Next, we take our value for x and substitute it into the function f. We get f of negative 2 equals negative 2 squared plus 4 times negative 2 minus 5. Next, we simplify. Negative 2 squared is 4. 4 times negative 2 is minus 8. And then we bring down the negative 5. From here, we combine together the 4 and the minus 8, which is negative 4. And then we bring down the minus 5. Minus 4 minus 5 is negative 9. So f of negative 2 is equal to negative 9. Our vertex is at the point parentheses negative 2 comma negative 9. Next, we need to find any x-intercepts. We just take our function f and set it equal to 0. We get x squared plus 4x minus 5 equals 0. From here we factor. We get parentheses x plus 5 times parentheses x minus 1 equals 0. Next, we apply the zero factor property. We get x plus 5 equals 0 and x minus 1 equals 0. Solving the first equation for x, we just subtract 5 from both sides. The result is x equals -5. Solving the second equation for x, we just add 1 to both sides. The result is x equals 1. Since we have two values for x, we have two x-intercepts, which are at the points parentheses -5, 0 and parentheses 1, 0. Next, we need to find any y-intercepts. So we just take 0, substitute it in for x into the function f. We have f of 0 equals 0 squared plus 4 times 0 minus 5. After simplifying, we get f of 0 is equal to -5. So our y-intercept is at the point parentheses 0, -5. Next, we're going to go over finding the maximum and minimum values. Below we have two diagrams. In the first diagram, we have a parabola with the equation y equals a times the parentheses x minus k squared plus k. We have the vertex at h, k, and the value of a is less than 0. This means that a is going to be negative and our parabola is facing downward. Whenever the parabola is facing down, this results in a maximum value that takes place at the vertex. Specifically, the maximum value is the y-coordinate of the vertex, which is the value k. Moving on to the second diagram, we have a parabola with the equation y equals a times the parentheses x minus k squared plus k. We have our vertex at h, k, and the value for a is greater than 0. This means that our a value is positive and our parabola is facing upward. Whenever the parabola is facing up, this results in a minimum value of the function, which takes place at the vertex. Specifically, the minimum value is the y-coordinate of the vertex, which has a value of k. In the next example, we're going to have to find the maximum or minimum value to solve the problem. In example number 3, a rock is thrown upward from the ground. Its height in feet above the ground after t seconds is given by the function f of t equals -16t squared plus 20t. Find the maximum height of the rock and the number of seconds it took for the rock to reach its maximum height. If we take a look at the function f of t equals -16t squared plus 20t, this is a quadratic function, which is the graph of a parabola. Notice that the leading term, -16t squared, is negative. This means that our parabola is going to be facing downward. So in order to find the maximum height of the rock and the number of seconds it took for the rock to reach its maximum height, we just need to apply the vertex formula. What we need to do first here is find our values for a, b, and c. Since our function is in the correct format, we have our a value is -16, b is equal to 20, and c is equal to 0. Next, we apply the vertex formula. Now be really careful. Notice here our function is f of t and not f of x. So the first coordinate of our vertex is going to be t equals -b over 2a. Next, we substitute our values in for a and b. We get t equals -20 over 2 times -16. After simplifying, we get -20 over -32, which simplifies to 5 over 8. So we have t equals 5 over 8. Plugging this into a calculator, we get the decimal value of 0.625. Next, we need to find the corresponding y value. So we take our value for t and substitute it into the function f. We get f of 5 over 8 equals -16 times 5 over 8 squared plus 20 times 5 over 8. Next, we simplify. 5 over 8 squared is 25 over 64, and 20 times 5 over 8 is 100 over 8. So we have -16 times 25 over 64 plus 100 over 8. Next, we multiply -16 and 25 over 64. We get -400 over 64, and then we bring down the plus 100 over 8. From here, I reduce both of the fractions, so we get -25 over 4 plus 25 over 2. Next, we add them both together. We get f of 5 over 8 is equal to 25 over 4. When we plug this into a calculator, we get the value of 6.25. So the vertex is at the point parentheses 5 over 8, 25 over 4. This means that the rock reaches its maximum height at the time 5 over 8 seconds, and that the maximum height is 25 over 4 feet. For the final answer, it is better to use the decimal equivalents. So we can state that the rock reached the maximum height of 6.25 feet in 0.625 seconds. Alright, well this is the end of our video. Thank you very much for watching. I'm Professor Diwa, and I'll see you in the next one.